Thank you to be back again. We try to catch up a little bit with the delay. That means that the session we start now, and we should finish at a quarter to 4. So please, when you present your project, do it as fast as possible. To reserve time for discussion. Okay, I just introduced this session. Just to give an overview of this first conference, European Conference for Factory of the Future Joint Dissemination. I think it's a good idea, and thank you very much for participating to that, because I think it's the first time we are doing such event, and as we already said, it's an open networking place for sharing ideas between FOF experts and to build up the future together. So let's go a little bit. So I resume a little bit from the objective to solution. We have the 3 sessions. As you know, it's very, very difficult to categorize the project into which session we should belong, because we have discussed with many partners. They would have agreed to belong to session B, they want to be to session B, and whatever. So this is a long discussion about that, but nevertheless, as I said this morning, many topics like, for example, interoperability is the hot topic concerning the 3 sessions. So we take time to discuss again about that. The session B is mainly a big session because we have 12 projects to present. I will skip a little bit the FoFdation project because we do it, as I am a little bit a communist also. I do not have a success story because we are all successful. We are equal. So we will present very quickly all the projects, and afterwards I think it's better to reserve time to discuss about the common issue. Among these projects, not all projects are IP. For example, the statement project is a research for SME. Wesley from Bath University is not here. Yeah. Ah, you are here, sorry. So he will present this project and our leading lab, in a lab we are participating to this project as an end user, not as a developer. So it's quite interesting to hear about that also. And okay, let's give a little bit our vision about the factory of the future in 2020. As many people were talking already, saying already this morning, the factory of the future would be, of course, human-centric. That means better serve people, and of course workers, and should be ubiquitous and predictive. This term of predictive already mentioned this morning. I think it's very important when we talk about automation, when we close, we have to optimize. The next step, we should be able to predict the future. And of course, environmental friendly, to preserve our planet. So we have the 3P, not a private-public partnership, but people, profit, and planet. And all these things, of course, are tightly IT dependent. So today, when we talk about manufacturing technology, I think that IT is playing a key role for developing next manufacturing system. You know, in the past, I used to work for machine tool builder, and some 20 years ago. And when I talked to machine tool builders manager, I said, okay, the future of the machine tool is no longer only mechanics, but it will be composed by mechanic, informatics, IT, and electronics. And at that time, the machine tool builder manager didn't believe that. So this is, but today I think this is make a step further, and if you look at all the machine tools today, all of them are unfortunately depending on Microsoft. Microsoft is not here, so I can say. Okay. So what are the next trends regarding IT? We should use Internet of Things and RFID also. Proactive computing model and integration. Integration is another key issue tightly linked with interoperability. We should be interoperable to be integrated. This is the difficulty to achieve. So integration mainly concern horizontal transaction, and interoperability mainly concern the vertical process. For example, let me give an example, the controller of the machine. Today, you have the KAP, the process for manufacturing, you go from the KAP system to the CAM system and the controller. We can envision that in the future, we skip the CAM system. So maybe there are some CAM builders here, they will not agree, but I believe that in the future, the CAM system could be embedded directly into the controller. But let's see. Manufacturing is a big market. This is to address our politicians, but unfortunately we don't have politicians in this audience because they are talking a lot about life science, medical system. Of course, if you want to make a progress in life science, you have to produce, you have to manufacture instruments, because all the technology for life science depends on instruments. So instrument is mechanical engineering integration with mechatronic system. So I think it's very important. But today, manufacturing is still a very big market, €2 trillion worldwide. So, and you have a rich assortment of products which interface with human, because whatever you do, you need concrete, real object. Even the computer, you need the mouse, you need the interface, and all these things depends on manufacturing. And of course, we have a high potential for productivity improvement. The image of industry today is all sector, and we still have a big gap for IT enabling. You discussed with many SMEs upstairs, for example, most of them do not believe enough about the integration of IT in their business model, etc. This is still the case today. So there are also a strong need for environmental friendliness. You know that manufacturing is consumed today about 30% of energy, etc. And so other sector is the building sector, and building sector is, and manufacturing sectors are also very tightly linked together. Okay, so this is Jean-Bernard proposed it already this morning, so I keep it, but I think it's very important for us, engineers, to ask very simple questions, because if you go to the manager, I'm sorry to say that, most of the manager, if you talk about interoperability, they do not understand what does it mean. But you have to talk about make a part better, or to buy it, to produce greener, and to manage smarter. All these things, this is the vocabulary of manager. But don't talk about interoperability or SNOPs, interoperability, whatever, they do not understand it. Okay, here is the roadmap proposed by FR for the FP7, and I repeat it again here, but I just highlight that we cannot do smart system if the system is not yet modelized digitally. So today, I'm very happy to learn this morning about the next call and the next program. Digital is a key issue. We have to digitize everything, process, product, resource, make everything communicating together before talking about smart system or virtual system. So, here's the key topics. This RR means Rough Image Schneider. slide come from you? Maybe you talk about this morning. I can skip it and we can talk about it again at the end if you agree. What would you want to give us a few words about it? Okay. This is the new. Okay, this slide also we have seen it already. So what is smart manufacturing? Smart manufacturing is defined by all these things. And when I talk to that with Jean-Bernard, for example, he say, okay, information is all. But how to manage all these things by a unique backbone or MIP, the term we call in our project manufacturing integrated pipeline. Okay, integration is a key issue. And I think that this slide originally is not from me, it's from Professor Dr. Harwick, you should know him, he's on, I forget his name, from the US.
A lot of professors in the US.
Yes. Yes. Okay, and I think it's quite interesting. And so I completed, you can see here, what is the description of the factory. You have the process control in real time, you have a micro-planning like to define cutting path for driving machine tool. You have a macro planning to define the different feature and the different technology to produce a part, and production planning also. And you have the highest level enterprise management. And all these things depends on the temporary decision scale, real time, plan level, near time, or any time as a corporation level. And here you have the mapping with the objective expected by the management: part quality, sustainability, productivity, and profitability, of course.
Okay. Professor Blanquet.
Sorry?
Professor Blanquet.
Okay, sorry. Okay, so I go a little bit fast. Today, many people are talking about big data. If you type in Google big data, you have plenty of page to read. It's very quite interesting, but sometimes it's not easy to understand also. So everything today can be captured. I hope that we will not use this big data only like NSA, as US, United States, but for better optimized manufacturing system. Okay, so the success story we should highlight is to integrate that for some smart manufacturing. This also from our officer, to give a consolidated view on the portfolio of major activities, make some story. This is the recommendation for our project presenters. Okay, so let's talk quickly about FoFdation, but I skip because we already showed it this morning. I will go back later on when we discuss about interoperability, things like that. So let's say, to resume, FoFdation, we are taking over different aspects. At the level of shop floor, that means we want to produce a next generation of machine tool controller. At the same time, we want to enhance MES system in order to take in account the sustainability issue. And last but not least, we want also to manage assets of the company through some kind of PLM system based on the market, like a team center from Siemens. This is one remark also. I would recommend project coordinators or project consortium to take into consideration the product coming from the market, because people from the market, they are doing a lot of work, intelligent work too, so we have to take care about them. Sometimes some researchers tend to reinvent the wheel in some way. So this FoFdation is a very ambitious project. We are at the 3 levels of the factory, so I don't want to go more. I just say FoFdation, what else? So the next step, PlantCockpit.
Martin Wollschläger. I'm from Technical University of Dresden, and we are one of the partners of the PlantCockpit project. We have talked a lot about integration. I think integration is indeed the key issue in order to come up with a system that is considering environment, that is considering the appropriate technology to produce better products. And we also talked about data awareness, etc. So I don't want to repeat all of that. But when we look into current systems, we see our good old automation pyramid, and we know that there's a lot of data coming from all the different levels. And without accessing this data, we are not in a position, I think, to highlight all these topics that we discussed before. So what we need is kind of a platform in order to do this integration, to access the already existing proprietary system. We'll talk about standards tomorrow. Standards are a great thing. Everyone should have its own. It's a good old joke. And we need to address existing legacy systems in order to come up with an integration part, in order to have a platform to do some specific analytics, getting the processes better in shape. And of course, we also need a flexible kind of visualization in order to get the data to the customer, to the end user in the right way. So what you can see here is an architecture that we developed in our system. I don't want to go through all the details. It is based on a kind of concept that comes from the automation and control, that is function blocks. And we extend these blocks to the upper layers of the automation pyramid that goes going into the MES and ERP level as well. What does it mean? It gives us kind of a platform of reference to put in analytics there, to have interfaces between all these blocks, that they can be easily connected, easily to be said. This is also true for addressing the underlying legacy systems in here. And we also have a similar approach that is based on modularization also for the topics of visualizing all that. And of course, we also care for technologies that have been discussed this morning, for example, for configuration of the system of the different blocks. We need some support. Our support that we want to provide here is also using a semantic approach, and so things come together a bit. Good. The demonstrations, the demonstrators that we are setting up here, they also reflect some topics that we have discussed this morning. We have obviously an application that is going to the energy consumption stuff. Our project partner Intel, for example, is doing this for semiconductor production. Another one is the visibility of processes. Beside integration, we also have a kind of an aggregation of information. And that finally leads us to key performance indicators and all these nice things. These key performance indicators are depending on each other, and these KPI trees you can see here on the left side, mainly something that is relevant for our partner BMW, in order to drill down into the processes and to see where is going something wrong, to be aware of some problems ahead of influence in the system. Yeah, and finally, we have to protect our assets that are in the production process, so asset optimization and asset management is something that is also discussed here, especially with partners like Comau. We're doing some demonstrations here, and yeah, I think depending on the time, that should be enough for PlantCockpit. I would be happy for questions later on. Thank you.
Hello, my name is I'm from Berlin Institute of Technology in the Department of Machine Tools and Factory Management. Thank you for give me for the opportunity to present here KAP project. I will give you a rough main idea, a model, what we are talking and what we are making, what we are addressing in the KAP project. We have two topics. One is waste reduction with better maintenance, and the other is increase the energy consumption of manufacturing systems. And we hear today a lot of ideas that we have a lot of information we use and make data analyzing and to predict something. And I try to give a rough estimation, a rough introduction. So the first topic is information. Around about 20 years ago, the factories start to collect a lot of data from their processes, from their equipment, but it was just information. Because if you not generate benefit out of this information, it becomes not a knowledge. And what we tried was to develop a standard how to define process KPIs, performance indicators for the production systems and for the organization indicators. The next step is communication in the sense of how I can be aware about my production systems. For that we need sensors, and the next question is here, okay, what kind of sensors do we need? To make a factory smarter is not, I mean, the first idea was to put a lot of sensors to sensor the processes, but the relevant question is what kind of information could we get? What is the real information, what we need? And I will shortly introduce the idea from our use case partners. So we start with the Volvo use case. There we have traditional manufacturing processes. There is a production line for cylinder heads, and they have also implemented the expert knowledge software with several sensors, where they could detect the states and so on. And what we tried was to make first the energy consumption of their production visible, to show what is, how many energy is used where, and where the losses. And for that we put energy measurements, like power measurements to these machines. And what one kind before addressed, Professor Dornfeld showed us how we can identify on the power measurements the different states of the machines. It means we need just the power measurement from one machine. It's a stream in milliseconds or seconds, and we develop algorithms to make to analyze in real time these power data and produce indicators in the sense of power over time, for the production, for the main value-added production process, visible indicators. And based on that, now we can do the interesting part, it's more analytics. So we can collect these data for different process steps and make forecasting systems. And if we develop a model, we can also go to and try to predict failures, for example, or also to predict when it's better to shut off and shut on, switch on the machines to reduce the standby energy consumption, for example. So there's a kind of loop in the end what we create. The main target is efficiency and effectiveness of man-machine controlling methods. And for that, we put sensors in the line, mainly power measurement sensors. The second thing is to visualize this information, make it human readable for your operator. And we address different stakeholders there. One is the operator on the machine. He need to take decision in a very short time. It depends on seconds, milliseconds, seconds or minutes or hours if you need to shut down the machine or not. The next level here is the line level. There we have a production planner. He have a horizon for his schedule maybe of 1 week, 1 day. And on the top layer we have management. They're taking more strategical information. And with this concept, it is possible to show on the management high aggregated level really the value-added processes in the sense of that we can integrate bottom-up and visualize this information on the dashboard, which is stakeholder specific. And this leads also us to make decision regarding these real measured data. So the next, what we achieve and results, we developed several prototypes, and we have now 6 prototypes roundabout for each use case partner. And what we did there is analyzing manufacturing operations and energy consumption of application partners. So definition product and energy optimization strategies, because if you want to know or validate your strategies on the optimal, like operation strategies, tactical strategies, or other strategies, you need a valid parameter to improve them. And with SAP and Microsoft mainly generated a platform where we could handle these real-time data and transform it, make it visible for different stakeholders. CDP is here complex event processing, so everything is very complex. It's also an issue. And the last is designing visualization and support tracking of KPIs in the real environment. For that, we have also tomorrow a short one slide in the standardization workshop where we could go deeper. The next issue is how agile and environmentally friendly manufacturing is. So the objective here is high flexibility and integration of shop floor-based platforms in seamless cooperation with enterprise software. We have also cooperation with PlantCockpit in this to realize these data. We also generated an architectural model of the factory where we could integrate the real measured data very easily and calculate it on different layers. So the next is more interesting for us because our customers are mainly SMEs, so the metalworking sectors in Germany. And here we need constant context and user-aware ICT and scalable network of sensors. It means we have their polarities in our project also. The big supplier like SAP or Microsoft, they will have a holistic solution for all manufacturing systems. And in our case, we need to have customized solutions for our SMEs. And there is a gap between them, but I think we have a good solution with modularity systems. So we have a module prototypes where we can plug and play for the SMEs. And the last is the main idea with what I'm talking here. If we consider electrical power, and we have this question, what kind of systems could we analyze with that? The answer is very interesting. We can analyzing all systems where electrical energy is converted via electrical motor to kinetic energy. It means around about in Germany, if we're just considering the industry, it's 4% of the primary energy resources which is converted in this such of kinematic systems. It means if this model or if this approach became a standard, we can imagine what kind of loops or what kind of controlling loops we could have in a total engineering maybe. Dissemination and exploitation activities. There is also a problem between academic partners and industry partners. We are academic partners. We try to disseminate everything, every results, and show it and share it. And on the other hand, the big player says, "Oh, moment, it is core information. We can't share it. But if we write a paper and the use case partner take all the data, then it's hard to make a good dissemination activity." So we identify 6 indicators to measure our dissemination activities. The first, we ask all partners, okay, we have several fields. Please give a number, end of this project, how much activities you would spend for that. And the first area is the publication and presentations. Now, this is, for example, a dissemination activity. We share information. Sorry that we can't go deeper, but if you have questions there, it would be appreciated for me to discuss more deeply. The next topic is peer-reviewed scientific publications. So that is our main value creation factor for the academician part. The next are events. We're organizing also, we have a conference in September, I will refer later on it. And also education is very elementary for us. We try to educate master students in several student projects where we defined smaller targets with real data and real use case applications. So we hope the quality of the education became better through these dissemination activities. Then we have also a huge network of collaborations. I will show later one slide. And communication platforms also, where we share information, next events, next workshops, and and also we have 2 patents in the pipeline generated since now out of this project. And here I will invite you also to our conference. It is a global conference on sustainable manufacturing. It's the 11th one. It's a conference which is mainly organized from our department and collaborative and finance from the Collaborative Research Center. It's a huge project which is going 12 years. The issue here is to create sustainable value creation networks and to make it also make assessment on it and regarding also new technologies. And ICT is in this field main inhibitor for sustainability in manufacturing systems. We also could see here the partners. The MC Factory is a very a partner from us, ProSuite. We have also an INS proposal, and we will have also a smaller project and workshop meetings here on this conference, where we could go deeper and discuss relevant topics. So it is finishing. I will finish my talk with Konrad Zuse. Das Mensch werde wesentlich. I think there is a main critic for all ICT, all projects and all scientific research. I tried to explain it, I tried to translate it to German, but it was not possible for me. So I hope the German colleagues could try to translate this critic to the non-German speakers. Thank you.